Unfortunately, our next presenter just, so he said he just flew in from a dark meeting in DC, but he is located in Dayton with Parallax Research. Steve and.
Sure. You guys are gonna be okay? I've got a pretty loud voice, so what's that? So I work with Parallax Advanced Research. I don't know if you've heard of Parallax or not. It's a nonprofit research organization. We're not real big. Probably, Ethan, we're not big. We're like 150 employees, okay? But we're mainly PhDs in research. We do fundamental basic research, but we also do applied research, and we also have in-state products that we end up supporting, if you will, right? Someone else may produce it. Yeah. And so I do both cyber attack and defense. I do it for DOD, DOW. I'm not quite sure what is correct right now, so I'm thinking of either DOW. Yeah. Okay. It worked actually. So pretty much if it's research, we do it primarily for the nation. However, we also do it for commercial customers. We're in both spaces. And we're all over the country. We have an office headquartered in Dayton, Ohio. And then we also have the Ohio Aerospace Institute. We're like combined with them. And they're in Cleveland. And then also we have an office in DC across the street from DARPA. I was at DARPA yesterday today, going over some DARPA activities. A roadmap. Anybody familiar with Wright State University? Yeah. So in the beginning, we were the Wright State University Research Institute, and we're now Parallax. So we're independent of the university. That's all that's happened. We're making agreements with all kinds of universities throughout the state, and we haven't got an agreement with your university yet, and you'd like to do research with this or organization. I mean, you could be another business. Please see me. And we do that kind of thing. You team up and work with others. If you're going to do some research that's really impactful, disruptive, you're not going to do it alone. Okay. So, so I do all things hardware, but I also do all things software. Quantum, neuromorphic, sort of neuromorphics. Couple of people, yeah. So I'm going to talk about neuromorphics, bio-inspired computing, spiky neural networks, some sort of spiky neural networks. Okay. So yeah, and CNNs and things of that nature. I'll talk about our data centers and do some comparisons. Then someone's got to watch me on time because I tend to kind of ramble. So someone's got to make sure I don't do that. Because I stand between you and lunch. Right, I think I do. So that's usually a dangerous place to be in. Yeah, so we're covering, airborne systems, ground systems, all the services. We do that, and we specialize in neuromorphic algorithms, which is a little bit. We've got to get the community more widespread. So part of my mission is to tell you guys about SNNs, that type of thing, because of the data center power use problem. If you're not aware of it, it's pretty bad. We're going to have to go over to a different type of architecture than the standard 911 architecture. We have to get away from it. Okay, and it's period, and it's going to be totally different. Okay, in order to, I can reduce the power consumption orders of magnitude less, and then also increase throughput speed and also accuracy by going to this other type of. It's more the same. Of course, you know, the organization wants me to use their slides as I kind of open things up, so I have to use it.
Yeah.
Okay, so, sorry, now you can't see it probably at all, because I didn't think it was gonna work well. But, you know, deep fakes have been talked about, and malware, but, you know, it's now, if you didn't know, AI is now in the game. So AI is attacking your systems. Deliberately. Okay, if I, you know, when I do attacks, I do it against bad out of country folks. Okay, so I'm going at, right? And I'm gonna use AI. And I'm going to, what am I going to attack? Their AI. Okay, so, we're gonna also defend our systems at the same time. And, as you develop stuff to defend your system, you better know how to attack it and vice versa. You gotta be able to do that. Okay, drones. Have you guys seen the news? Drones, Russia, putting some drones into Poland. You guys know about this? It's not good, right? And so that's caused a very urgent need. One of the projects I'm working on is, so now I'm involved in taking out drones, but not with kinetic weapons. Kinetic weapon is like a missile. I'm doing, pretty quiet about this, but other methods, okay? All right, so the human brain, so I guess the title of this sucker was Brain versus Bots or something like that. So, yeah, GPUs, you know, the megawatts. When you get to very, very large computers. Okay. They just keep on doing more GPUs and they keep getting bigger. Anybody have a gaming laptop, or has anybody done machine learning in here? Right, GPUs, you know, you could heat your house with some of these stuff. And they're, you know, size of a banana, right? You cook the breakfast on some of the GPUs. Okay, we're wasting energy doing this. Okay, so we've got to find a different way. And the brain, believe it or not, you know, in the exaflop world, you have to kind of, we do things differently a little bit in our mind, but we're right in there with a supercomputer. At 20 watts, a light bulb versus, what was it, 21 megawatts? So the thought is, hey, let's start modeling our processors like we do the human brain. We don't model the human brain, right? But let's do the processor like so that's the thought, right? Our memory is throughout our brain. We do compute in memory. We don't go off our brain to some other body part to do memory. Okay, so are we doing that with the microprocessor? I don't care if it's next door, but it doesn't count. I'm talking about inside the pod. This is an eye opener. I can just do I can just change one pixel. Okay, if you're doing image recognition stuff, for whatever reason, I can just change one pixel. I do this kind of stuff. And I can just start really ruining convolutional neural network developed AI. I can start ruining it quite quick. But if it's a spike in a network, it's a lot more difficult. It's a lot more resilient, a lot more robust. I've done this in experimentation. Pretty much, this is just 1% of a pixel. If I, you know, do like, you know, 20% of a pixel, my CNN developed AI is useless. 50-50, you're guessing. Just 50-50 is guessing. I mean, I can just go ahead and do that myself. But I'm still at least, you know, about 70% with the SNN. Very resilient to that. And they're much faster. Okay, speed is life. So when I can outmaneuver and do things much faster than SNN, I'm just ruining the day with CNNs. Harbour is wrong. So in our brains, right, we have neurons. I'm sure everyone knows this. Biochemical process. And then we have the and spikes. If they send messages to one another via spikes. And, minus 70 millivolts, so very small voltage, right? Actually potential up to 40. And when I hit a threshold of minus 55 millivolts, so sodium, calcium, they're separated by a membrane, and they're ions, right? And when the charge is just, I can model this in one short. Sure can. Okay. And it will fire and it goes to the next level. Okay. Now the message, it's either blocked or received and another activation. So I can model a computer this way. I can model a computer this way in software. I can model a computer this way in hardware sim. So I'll talk more about that. Oh yeah, so something called a living processor. So I'm the lead innovator and PI for this. And this is what I was talking about. So basically I have organic and you can't go on by this, right? This is really, basic going up through applied research. But you can, so I'm using organic and inorganic layers. We're trying to get away from CMOS. Yeah. Okay. I also use earth abundant compound. This is a self-healing processor. It will repair itself. And it has some other attributes that I cannot discuss. A lot of layers. It will blow your socks off. And very hard into the not just space radiation, but also some, and also a lean cycle. You guys have heard of blockchain, I'm sure. So let's do it there more. I can do it with all those energy usage. You can do it on fast. An SNN is a fighting CNN. So there's many varieties that you can do with SNN and CNN. And you can get the right, the challenge is getting kind of like the right combination. That's rather challenging. It takes a lot of work, but it's doable. And so I've got several research papers in this area, all the papers, and then some more that can't be published. Right? And of course the drones are there because we're doing good drones. And you're right, the continual learning, got my curiosity at big time, folks there. Because online learning it's good, but caution, right? Because if you start doing some fake outs during the online learning process to the system deliberately, you can make it ruin the system today. So ways to mitigate that. So this is kind of hard to see. So this is a comparison based on the research that others have done and I have done in the community. And you can see that the energy use of a CNN is because it's constantly, right? So think of it this way. Our brain is of interest, right? We're not clocked. Our minds are not clocked. Microprocessor is clocked. I don't have to clock an airborne processor. The event clocks it. So nothing's going on. I'm not like in La La Land, but I'm not having to do computations. If you're in an environment type of situation in architecture, you're having to constantly do computations. And if you've done SNNs and backpropagation and the linear matrix algebra and the backpropagation and partial derivatives, very good at feature extraction, but it's a lot of compute, a lot. And so you're eating up a lot of it, powers. You need a lot of power, right? And I don't do that with an SNN because it's like we're very good. You just show us a few pictures of a coyote. I probably got to recognize a coyote. I want to train a CNN on a coyote. I better give it 1,000+ pictures. Oh, okay. Oh, I'm really good at it. And then the latency. So it's hard to see. But the SNN is just much faster. You've got to really get if you really want to, especially when we start going into this area, we're gonna have to get to the microcircuit. Milliseconds or slow, too slow. Okay. And you just can't, you gotta go with this. So yeah, I think we know, is it, electronic warfare, anybody know what electronic warfare is? Yeah. So basically it's kind of like, a little bit like the cyber attack and defense for civilian organizations. So, the bad folks, the bad actors, say for example, they want to shoot down airplanes, right? Well, and what do they have to use? They're using electronic information, electromagnetic radiation, right? To track, acquire, launch, follow, hit. Well, if you can monkey with that, you can defend your airplanes. So that's electronic warfare, or you know, electronic attacks. Well, that attack. So in a different kind of way, it's all like cyber. Go ahead, sir.
What was that term again? Something warfare?
Electronic warfare.
Oh, electronic, okay,
Yeah,
sorry.
yeah. So I'm involved, heavily involved. Absolutely. And then, you know we have infrastructure, right? So, Harbour grid in South Carolina. You guys know what's happened. Bad, 100,000 people lost power and lose 200. Yeah, problem. So not only are we sucking our power grids pretty harshly, and then how about the data centers? We got to defend the data center. Well, so we now have a larger footprint thanks to the better side of the past. Actually, so you have range, not reform. So back to the original theme is you gotta, biological range or biology, think of it as biology. Biology has evolved for a long time, right? Based on DNA type stuff. And so nature got it right. So we should look to nature to build our computing systems. And I think we can, I know I can defeat systems that aren't in that realm with that. Of course, when the day comes, everyone's in that realm, well, then now it's going to be, then we'll figure that one out when it happens, right? But yeah, we really have to get away from that one now. Which is going to be, what do you call that? I'll take questions.
So in terms of using like a bio-based like network or architecture, is there like an issue with like degrading of the biomass? Yeah.
Is that what they're gonna? So, yeah, good question. So here's the good news. First of all, I'm not using real fleshy, rain material that comes out. So we'll make that really clear. We're not doing wetware. But it can be a challenge with organic material, right? So we're working feverishly on organic material that doesn't have that issue. Because that can be a problem of not being as, harsh, if you will. And there's things that we can do in the layer building with processor that protect that organic layer and then also allow a repair action to happen. On its own, right?
Hence
And then we're computing vertically and horizontally. And it's going to be, go ahead, sir.
Are you guys manufacturing any of this at scale yet, or is it still mostly?
Yeah, not at scale yet. Yeah, so I've done a lot of work with Mike Davies at Intel, San Jose, and neuromorphic processors, LoGiHi1, LoGiHi2, and they're real good at edge. They're research chips. You can't go blind these. They're real good at edge computing. They're not scalable. That's a problem. Anybody know a brain chip? Range, check them out, Range Chip. They have an Akita 1000 that you can buy. They just put it in commercial availability, you can buy it. And, around $500. And you can start working with it, playing with it, okay? It's not a full neuromorphic chip, it's still digital. It has a neuromorphic mesh, so it behaves kind of in a big way neuromorphically. But it uses a lot less energy. And has very good accuracy when trained, you know, when the final result you've employed the algorithm. But again, it's edge, it's at the edge, which is very good. So the living processor that I put up there, that one will be, can do dual role at the edge, but then also in the data center. The memory capability, I can't say what it is, but it will blow your mind away. It totally will blow your mind. And we have memory, computing memory, and also storage within the layer. Yeah, you can replace buku racks of GPUs in a data center. So, how fast is that going to happen? Is it going to happen in a year? You know, it's going to be a little bit of time, but we have to get there as fast as we can because we're getting more and more data centers. Everyone's now doing the shopping list with ChatGPT apparently. So, and that's what funny. It's a great tool. I think it's dual as steroids. Somebody has, yes, sir.
Are the big GPU providers that are out there already leaning in this direction? Have you seen evidence of that?
So I have not seen evidence of that. So NVIDIA is a pretty powerful company. You know, when I was doing their market research at Intel, across the street from it, almost across the street from NVIDIA in San Jose. I would think about that. Aren't you guys at least thinking about this? So I have no indication they are, but you know, my sixth sense is they're probably going, you know what? We don't want to be the dodo bird, the dinosaur, right? Some companies have done that and then they get bad, right? So, but I'm not seeing, if they are, they're being really quiet about. IBM has a couple of, has North Pole, which is, again, it's a digitally based neuromorphic mesh chip in research. So it's, you know, starting to see that. Raytheon has, I'm not a business guy, but I've been told that Raytheon's bought some stock, quite a bit of stock in BrainChip. So, you know, it's starting to happen, momentum's trying, everyone's seeing the writing on the wall, starting to happen. Yeah, so, sir.
So are these Loihi chips from Intel, are they like purely analog? And also if they are,
Yeah. They're not analog,
okay.
unfortunately. So they're digital. The living processor is mainly analog, some digital. You know, and for an absolute pure neuromorphic, it's analog, right? And I know what? It's not like going backwards. So Dr. Carver Mead at Caltech in the 80s developed a analog chip. He's really the father, if you want to go back, of all this new development. And the digital processor won out. I haven't done history. I don't know why. So, yeah, analog, and you know, but we live in a digital world, so you have to kind of do, so you have to do some conversion back and forth, but we have a patented way to do that for low power use during the process. Because usually you can eat up power. Yeah.
I was gonna ask something along those lines, like, what's the interface between this biological level to current standard?
Correct, so that's why right now you gotta have some digital action going on, so you can communicate. It's normal, you can do a USB, you can do all the different type of interfaces that any other experimental board would use, or just alligator clips. Get really crude.
So it's just voltage readings?
It's just voltage readings.
Okay.
Yeah, exactly, and you could, absolutely, go different. Yeah. Sure.
Can you say more about the computational medium that you're using, and more specifically, have you considered using mushrooms?
Mycelium?
Yeah.
So, I can't tell you about the composition, sorry. I'm sorry, I wish, and this is, I know, because, I'm all into, so when I do academic, when I'm public, at a journal or conference, I put my more academic hat, right? But I'm like, so I can't, and DARPA is involved, so, but it's a great question, and it's a good question, by the way. One I'd ask. Mycelium, so the answer is, I'm doing research in mycelium. You guys know what mycelium is? You do, obviously, or you wouldn't have asked, yeah. So, under our feet, the trees are talking. Okay, so, everybody's got trees, we have stuff, underneath feet, right? There's communication going on, guys. It's going on, okay? And it's going on in a spiking fashion, like our brains. And there may be some language going on too. So yes, the answer is yes to your question. I was just with DARPA very much on that specific thing. So that I can share. We're looking for different ways, and I'm sorry.
Oh, no, it's all right. It's hard to be like.
That's tough.
As with the other speakers, please find them at break. Well, we're gonna break for lunch. We're